We're going to do a past paper, 2024 past paper. This should be 1120, yeah? So, useful to anybody who wants to review a first year um, university paper for mathematics. Okay, so it's a good foundation to start with, and we'll start with question 1. So, express 2022.3 recurring minus 5.25 in the form of a over b, where a and b are integers and b is not equal to 0. Okay, so how do we handle that? Of course, that's coming from rational numbers, right? So 22.3 recurring. What does this number mean? So this is exactly what you'd see on a calculator, where you've got threes just like that, not ending. So that's what recurring, or that's what the bar or the number represents. I believe we know that already. So if we were to write that in form of a over b, this one can easily be made in the form of a over b. So before we even subtract, I think let's convert this to a rational number. Okay, so I'll use this trick. So let our x be equal to that, right? What happens if we get to multiply both sides by, we only have one recurring number, so we can just multiply by a 10, so that we have 10x equivalent to 22. Now this 3 will move, so it would be 223. Remember, we're saying the number is 22.33 recurring, so if you multiply by a 10, you still have recurring 3's there, right? So it will still be 0.3. Okay, so this is still 3 recurring, by the way. So now we can try to subtract 10 minus the x, that would be 9x, and then we can equally subtract the right hand side, 223.3 recurring minus 22.3 recurring. The idea is we want the recurring parts to subtract, so then you remain with a 1, a 0, and a 2. So what is 201? So to find the fraction, it will be 201 divided by 9, right? 20 divided by 9, how many times? That's twice, because 9 times 2 is 18, so giving us a remainder of a 2. 9 into 21 is how many times? I don't think that's possible, so let's not divide by 9. Let's try a 3. 3 there is how many times? 6, giving us 6 times 3, that's 18, so remainder carry 2. And then 3 into 21 is 7, so we have 67. 9 divided by 3 itself is 3, so that is our fraction. Okay, so we've converted our 22.3 recurring to the form over b, 67 over 3. So if you have a calculator, actually you can try that. Punch 67 over 3. If you convert it to a decimal, it's going to give you 22 point recurring 3's. Okay, so there we have that. So we can now have 67 over 3 minus 5.25. Now we'd have to convert 5.25 as well, which I believe you're able to a fraction. So we just have to multiply, move the decimal how many times? Twice. 1, 2. So that means we have to multiply by 100. So I want to make sure we don't change the number, so whatever you multiply should also be divided. So you end up with 525 over 100. So after multiplying the top part, the decimal has moved twice, and then we are still dividing by the 100. Okay, so you can try to reduce this. I'm assuming calculators are not allowed, by the way, in this exam, so that's why I'm trying to do all these things manually. So 5 into 100 is 20 times. Then 5, I think you can divide by 25 instead. I can see this is gonna work. 25 into 100 is like 4 times. And then how many hundreds do we have in a 500? We've got 500s. So that means 5 times 4 is 20 plus the extra. So I'll do this 500s. So in each 100, the 25 is going there how many times? 4 times. So we can divide each 100 by 25 4 times. The hundreds are 5, so 5 times 4, that's 20, plus the extra 25, that's 21. So we have 21 over 4. So we have 67 divided by 3 minus 21 over 4. And then at this point you're able to subtract this. So common denominator is the 12. 3 divided into 12 is 4. So we have 4 multiplied by 6, 7 minus 4 into 12 is 3. So 3 times 21. Okay. So at this point now you're multiplying 6, 7 by 4. 4 times 7 is 28. 4 times 6 is 24 plus 2, 26. So 268. 21 by 3 is 63. So 63 minus 268. That's going to be 8 minus 3 is 5, 0, 205. So I have 205 over a 12. So we've actually now expressed the difference of that in the form of A over B, which is a fraction, right? So we've handled the first part with confidence. And so in summary, you can't subtract a recurring number with a non-recurring number. So first of all, we would want to convert the recurring number into a fraction itself, and then even the other decimal number into a fraction, and then you subtract the fractions. Subtracting fractions, applying fractions will give you a fraction, or a rational number. So express the complex number negative 2 plus 4i over 1 plus 3i plus 2 minus I raised to the third power. So every time I'm actually teaching complex numbers, I always tell my students, just do me a favor and master one thing. I squared is equal to negative 1. That's enough. That's sufficient to help us simplify whatever we have to do. And then when it comes to addition and subtraction, go by the like terms. When it comes to division and multiplication, deal with a conjugate. Okay, so you understand what I'm talking about just in a second. In fact, multiplication deals more with this, and then yeah, you'll see. So we've got division there, so that's the first thing we have to handle here. Okay, so we have 1 plus 3i. So how do we handle that part? So we have negative 2 plus 4i over 1 plus 3i. For us to divide, we'd have to multiply by what we call the conjugate of the denominator. So the denominator is 1 plus 3i, the conjugate of that is 1 minus 3i. So we do the same to the numerator as well. Now if you're not new to complex numbers, you understand that each time you're multiplying a complex number by its conjugate, just multiply the like terms, because we understand the middle part will subtract. Let me show you what happens there. 1 times 1 is a 1, so we're using that one, and then multiply by the negative 3i. Now we can go to the second part. 3i multiplied by 1 is positive 3i. 3i times negative 3i is going to be a minus 9i squared. So you see that the middle part is actually cancelling out, right? So it's just as good as multiplying 1 times 1 and then 3i times negative 3i, which will just be 1 minus 9i squared. So that's what we do when you're multiplying the conjugate, the complex number. So in short, we just have 1 minus 9i squared for the denominator. For the numerator, we can multiply everything. Negative 2 multiplied by this part. So we're going to have negative 2 and then positive 6i. Negative 2 multiplied by negative 3 will give us a positive. And then 4i plus multiplied by the 1 will also be 4i. 4i times negative 3i, that's going to be a 12, a minus 12 actually, I squared. And then that will give us negative 2 plus 10i. Now I squared, we're saying I squared is equal to negative 1. So we're going to have, let's call this 10i minus 12. I squared is negative 1 over 1 minus 9. Now I squared is negative 1 again. So here we've got negative 2. Negative 12 multiplied by negative 1 is going to be positive 12. So we have negative 2 plus 12 plus 10i. So that gives us a 10 plus 10i, right? And then on the denominator part, negative 9 times negative 1 is a positive 9 plus a 1, 10. So we have 10 plus 10i over 10, right? You can divide by 10, each term 1, 1. So you just have 1 plus I. And then we have to add this part. So we can also try to simplify that part. I'm hoping it can also simplify. So 2 minus I, open brackets 2 minus I. So we're multiplying that 3 times. That's what it means when you raise the power to the third power. It means multiply this, whatever is in the brackets, 3 times by itself. So let's try to take the first 2 brackets. 2 times 2 is a 4. That 2 again multiplied by the negative I will be a minus 2i. Negative I by positive 2 is going to be a minus 2i as well. And then negative I by negative I will be I squared. Positive I squared. So that's for the first brackets, right? Multiplied by the remaining brackets 2 multiplied by I. So before you actually proceed and multiply, always it's recommended you simplify. So this is going to give us something like 4 minus 4i. I squared, I did explain it's equal to negative 1. So that's what you have. And then you have 2 minus I. So don't mind the way I'm writing because you don't have enough space on the bottom. So at this point, 4 minus 1 is a 3. So 3 minus 4i, 2 minus I. Can multiply again. So start with a 3. 3 times 2 is 6. 3 times negative I is a minus 3i. We'll now go to the minus 4i times 2, that's minus 8i. And then times the negative I, that would be a positive 4. I is multiplying twice, it's I squared. And so this simplifies to 6. 3i minus negative 3 minus 8 is minus 11i. And then plus 4i squared, which is going to be 4 times negative 1, because I squared, I did emphasize, is equal to negative 1. And so we have 6 minus a 4, which gives us a 2 minus 11i. So we have 2 minus 11i. So you've seen, each time you have something dividing, before you think of doing anything with other given parts, take it individually, divide it by multiplying by the conjugate, and then also simplify this part and then bring them together to be easy. So 1 plus, we just collect like terms when you're adding and subtracting. So 1 plus 2 will just be a 3i minus 11i would just be a minus 10i. So we've expressed it in the form of a plus bi, where a and b are real numbers. This is our a, that is our b. Okay, so you want it to be in the form of a plus bi explicitly, so you can say 3 plus negative 10, right, I. That's still sufficient, right? Okay, so very simple and straightforward question. Now look at b. Given that sets a is equal to negative 6, 4, b is equal to that, and c is equal to that, and that the universal set is having numbers from negative 10 to 7, find the following sets and display them on the number line. Okay, so I've been doing sets for quite some time now, so this is not going to be a struggle. So I just give you a tip. Feel free to pause the video and try this one out. Okay, so I've answered it in the next video, so check out the next video. In this series you'll be able to check out the solution, of course, after you've tried it out. Alright, so we've got an interesting question on sets. I think before I saw this kind of a question, I used to like picture it, imagine it, because this is a mixture of interval notation and also roster form. Okay, so I'll explain what I'm talking about. So in this case, our A is having members from negative 6 all the way up to 4, and then our B is having members from negative 10 all the way up to 1. So this is actually union with 2 and 7. Okay, so I have to explain what these brackets actually indicate before I move on to C. Okay, so this implies negative 6 is not part of a set, 4 is part, and so you understand what the others would mean, right? Okay, now this is an interval. So an interval, we've already defined by now what real numbers are. Okay, so real numbers, these are numbers that would actually tell us, for example, I like giving this example. Think of numbers from 0 to 1, right? So if I use these brackets, you understand that actually 0 and 1 are not actually included, right, in this set. But yet it's still not an empty set because there are quite a lot of numbers in between 0 and 1. So numbers like 0 0.1, 0 0.11. So you actually discover that actually we've got an infinite number of numbers in between 0 and 1. So that's in a set of real numbers. So that's what we're talking about when you see these kind of brackets. Then roster form deals with integers. Yes, so these are elements. It's not an interval. So it implies set C is having negative 3, 6, and 7 alone as members of a set. So it has got a finite number of elements. I think that's what differentiates it from these other sets A and B. These are intervals. This is just a list of elements. Now we are told that the universal set itself is an interval of numbers from negative 10 to 7. Find the following sets. Okay, so the first set I want us to find is the intersection between A and C complement. So this is quite interesting, right? Quite interesting. So the first step, usually what I like advising is let's do this. let's take note of our set C. That's negative 3, 6, and 7. So before we can actually get to find the intersection with A, we can actually find the complement of C itself. So it's better understood when you basically indicate the interval or the universal set. The universal set is having numbers from negative 10 up to 7. So let's call that our universal set. Now set C is getting elements like negative 3. So let's actually say we've got a 0 there. So it's getting elements like negative 3, 6, and 7 itself. So if I was to show set C on the number line, those would just be points. Negative 3, 6, and what? And 7. Right? So those are distinct, finite elements representing C. So if I was to find the complement of it, it would be something like this. 3 wouldn't be included, but all the way up to negative 10. So this is one part of C complement. An interval from negative 10 to negative 3, except negative 3 is not included because it's part of C. So it's a C complement. And then, just as you might guess, again it would continue all the way up to 6. 6 couldn't be included. Again it would continue up to 7, and then 7 wouldn't be included. So that is our C complement. And so where we've got an empty circle, it implies that is not part of C complement because it is actually part of C. Okay, so hoping you've understood that, we can actually, every time we're trying to represent such a set, we use the union set to connect the dots, right? You'll understand what I mean. So if we were to list C complement or present it in interval notation, I would say this is including numbers from negative 10 up to negative 3. Negative 3 is not included. Union from negative 3 again up to 6. 6 is not included. Again, union from 6 to 7. Again, 7 is not included. That's how we would present that. Now, this is not our interest here. Here our interest is to find its intersection with set A. Now, we are very sure of what set A is comprising of. It's having numbers from negative 6 to 4. So if we are to present that as well on the number line, it would be very easy for us to actually find the intersection, right? So let's just remove C since we don't need it anymore. And then let's just try to put now set A, right? So A runs from 6. So let's present a 6 there, negative 6. All the way up to 4. So 4, let's say 4 is somewhere there. 4. Well, 4 is included, unlike negative 6. So if we draw a line there, so this is actually presenting now, don't mind the line, it's not straight. So that is presenting now set A. Okay, so this is set A. Now for us to find the intersection, we just have to shade and see where they are overlapping. So this is shading now. We can see where they're overlapping, right? So for something to be part of an intersection set, it's supposed to exist in both given sets. So if we're to find the intersection of A with our C complement as required per question, let's try to analyze. We'll start with negative 6 there. Would we say negative 6 is part of A? Of course not. Is it part of C? Yes, it is, because it's part of a line. So, but it's not part of A, so it can't be part of an intersection. So we'll just, but we know that's where it's starting from. So negative 6. So we're not going to use this kind of a bracket. Instead, we'll just put a curved bracket indicating that it is not included itself. Well, again, there's a restriction there because the circle is empty, so it implies negative 3 is not part and parcel of C complement. So it can't be part of the intersection. So the intersection runs from negative 6 to negative 3. Both negative 6 and negative 3 are not included. But again, it will continue from negative 3 all the way up to 4. Now, surprisingly, 4 will be included because of this kind of bracket. It is shaded. So 4 is part of A. It is also equally part of C because it's part of C complement, I mean. Because C complement is running from negative 3 up to 6 continuously. So 4 is part of C complement and, of course, A. So that's why we have that bracket. These are the only parts where they're overlapping, okay, with an exception of the parts where I've got these unshaded circles or dots. I don't know how we can call them, or rings. So this is actually what we expected to present for the intersection of A and C complement. And then basically this gives you an idea of what we're talking about, right? So with that understanding, please feel free to pause the video and answer this last question, which is actually easier. So let's draw a first number line. We want to find C intersection B minus A. So first of all, find B minus A before you intersect it with C. So start with what is in the brackets, B minus A. B minus A means B without A. I like using that definition to make things easier. So our B is from negative 10 up to 1, and then let's say 0 is there. So from 1 up to 1, right? And then we also have it from 2 up to 7. So let's try to show our set B. So negative 10 is included, and then up to 1. 1 is equally included by the brackets. Okay, so that's the first part, and then I'll just have to make sure. And then we are moving from 2 to 7, except 2 is not included. 7 is. So this is B, that is also B as well. Let me just drop it a little bit lower. So we're trying to find B minus A. So we have to remove A from B. So where is our A? A runs from negative 6. So let's have negative 6 here up to 4. So let's say 4 is there. So our A is running from this point up to that point. Right? Don't mind my lines that are not straight. So negative 6 is not included. Well, 4 is by the brackets. So this is set A. Now we're trying to remove it from set B. So kind of like we're trying to remove the intersection part. So let's try to shade where they are overlapping. So all that is supposed to be removed from B. What remains is now B without A. So let's try to see what we're going to have. This part, negative 6, is not part of A, so we can't remove it. So it will stand as it is. So this part will remain shaded because negative 6 is not part of A. So we can't remove it from B. But well, all the way from negative 6 up to 1, where they're overlapping, all those numbers are part of A. So we're going to remove them from B. So B so far will only run from this point up to negative 6. And then this part is very well shaded for A, the 2 part. So 2 is part of A. It can be part of B. And then this part as well, A is shaded from 2 up to 4. So we have to remove it from B. So B at 4 would be a ring that is not what? A ring that is not shaded, because 4 is part of A. So we have to remove it from B, per definition of B minus A. So after removing everything, we've seen that B again is running from 4 up to 7. And so the remaining part of B after removing A, which we are calling B without A or B minus A, is only from negative 10 to negative 6, and then unionized from 4, where 4 is removed, so it's not included, and then we're up to 7. This is our B minus A. So if I was to remove the removed parts, this is what would remove, and then this is what would remain. And what would remain would now be called B without what? A. And then now our goal here is to find the intersection of B minus A with C. So I advise that when you're trying to answer these questions by yourself, what you do is after you've determined B minus A on a different diagram, draw another number line to actually now do the last part. So now we're trying to find the intersection with C. So our C is a very simple set. It's having negative 3, so negative 3 is somewhere there. And then it's also having 6, so 6 is obviously somewhere closer to 7, right? And then it's also having 7 itself. So we're trying to find the intersection. Where are they overlapping? So this part is not overlapping with any part of C. That part at least is overlapping with 2 points. So what is common between the two sets? I think the two numbers are common. 6 is contained in B minus A, and then 7 is also contained in B minus A. So try to guess what would be the answer. Do you think the answer would be 6, 7, or 6, 7? Okay, so if you understand the meaning of these two sets, then you know what the answer is. So the answer is the first part, because 6 and 7 are distinct numbers or elements of set C, and they are the only ones that are overlapping with B minus A. So if you are to say an interval, then you would imply that even the numbers between 6 and 7 are also part of C, which are not. So that's it for this question. Quite interesting, right? Yeah, it is. Alright, so we're on C actually. I wanted to say the third questions, but it's the same, yeah. So here we are rationalizing the denominator, and then we're supposed to express it in the form of P plus Q, and then finding a domain of a radical function, right? Alright, so we'll start with the first one. If you've got ideas, feel free to pause the video, try them out. So rationalize the denominator of that 6 minus 2 root of 3, right? Alright, so 6 minus 2 root 3 divided by 2 plus 2 root of 2 7 minus root of 4 8. So rationalizing the denominator implies that we shouldn't have a square root in the denominator, or a surd in other terms. Okay, so what do we do? So think of the root of 27, root of 48, think of ways in which we can simplify them. So root of 27 should be a product of what? Think of any divisor of 27. What can we divide 27? What's a factor of 27? I think that's a better way. What's the factor of 27? 9, right? I think 9 times 3 is 27. So share the square root. And then root of 48, 48, I think 48 is like, okay, any factor of 48. I think 4 is a factor. 4 times 12. Now 12 can also be expressed as 4 by 3. So 4 times 4 is 16 times 3 is 16 times 3 should be 48, right? Yeah, 48. Because 6 times 3 is 18. So alright, so if you try to simplify these, root of 4 is 2, root of 4 is 2, root of 3 remains as it is. So this is basically 4 root of 3. Root of 9 is 3, so we've got 3 root 3. So we have 2 plus 2. So root of 27, let me start with a numerator. 6 minus 2 root of 3 over 2 plus 2. Root of 27 is 9 times 3, which has now been simplified to 3 root 3, right? And then minus 4, 8, which is 4 root 3. If we try to simplify that, we're going to have 6 minus 2 root 3 over, this is going to be 2 times 3 is 6, right? So we're going to have 2 plus 6, this is 6, 6 root 3 minus 4 root 3. So you can see that these now become like terms. So we're going to have 6 minus 2 root 3 over 2, 6 minus 4 is 2. We maintain the side, so just focus on the numbers, maintain the root of 3. So at this point we can now see that what we add on our left is equal to 6 minus 2 root 3 over 2 plus 2 root 3. So this is actually easy for you to actually rationalize now. Just multiply by the conjugate, so 2 minus 2 root 3 so for the top part, 6 times 2 is 12. 6 times 2 again is 12 root of 3. This times 2 is minus 4. And then this times that will be positive 4. Root 3 times root of 3 is actually just 3. So let me just move this a little bit. So it will be 4 root of 3 by root of 3. Now each time you're multiplying a complex, or in fact this is not a complex number, this is a surd. Each time you're multiplying a surd by its conjugate as well, just multiply the like parts. So 2 times 2, that's 4. 2 times negative 2 is a minus 4. Root of 3 times root of 3 is just going to give us a 3 as well. Like terms, minus 12 minus 4 is minus 16. So we're going to have 12 minus 16 root of 3. 3 root of 3 by root of 3 is going to be 3. So we're going to have 4 by 3, which is practically 12. Denominator 4 minus 4, again root of 3 by 3 is going to be 3. So what we have So finally, after rationalizing, we're going to remain with, this is 12 plus 12 is 24. So 24 minus 16 root of 3 over 4 minus 4, which is actually 12, right? This is 12, so 4 minus 12 is minus 8. And then at this point we can actually choose to divide by the minus 8 throughout. So you end up with minus 3, positive 2 root of 3. So you've rationalized the denominator, okay? And we have it expressed in the form of a plus p plus q over 3 as requested. Simple and straightforward, right? Now, finding the domain implies trying to find the values of x that would define a given function. So our function is h of x, which is equal to that. So that's under a square root. So a square root, for anything to define the square root, anything that just makes the square root to be undefined is a negative, right? So each time you've got a square root, we know that 0 and positive numbers are determinable, but anything that does not, a negative 1, you can't find the square root of a negative 1. So we avoid complex numbers because functions are restricted to real numbers. So therefore, first to find the domain, our denominator, which is 2 minus, not our denominator, the value under the square root should be greater than or equal to 0. It can't be less than that. If it was going to be less than 0, then it becomes undefined. So what values of x would ensure that that is going to be greater than or equal to 0? The only defined values under a square root. So therefore, this is a quadratic, so let's start with that. So before we can answer the inequality, I advise for you to find the zeros of the equation. It actually becomes easier. So let's try if we can factorize this. Negative 4 times 2 is a minus 8. The sum is minus 7. This is the product. What are the factors? What two numbers can you multiply to give negative 8 here and then give minus 7? So it should be negative 8 and 1. So therefore we can end up with negative 4x squared minus 8x plus x plus 2 is greater than or equal to 0. For the first part, we can factorize. We know negative 4 is common, negative 4x, so we remain with x and then plus 2. The other part we maintain, so that we just have x plus 2. And then remain with negative 4x plus 1 and then x plus 2 greater than or equal to 0. So determine the zeros of this inequality. So equate this part to 0. Negative 4x plus 1 is equal to 0. Negative 4x is equal to negative 1. X is equal to 1 over 4. So that's one of the zeros. And then the other one is negative 2. Okay, so we can actually use these ones to test. I like using the number line. If you want, you can use the table. That's very, very fine. Let me use the table this once. I've never used the table in my videos. Let me use the table this once. Okay, and maybe if you like it, give us a comment. Let's see the comment if you like, if you prefer using the table. And then Alright, so what we have is, for the first part, let's put negative 4x plus 1, which is in the first bracket. The other bracket is x plus 2. And then, of course, this last one is supposed to have the entire equation, right? Okay. Now, remember, if I were to draw a number line, the two values that I gave you were negative 2 and positive 1 over 4. Those were the zeros of this equation. So I have to test these three distinct parts. Okay. So that is from values that are less than negative 2, and then values that are between negative 2 and what? And 1 over 4. And then also values that are greater than 1 over 4. Okay, so these are the ones that we're trying out. So any value that is less than negative 2 that you can think of, you can try negative 3. So what happens if you put negative 3 where there's x there? Negative 3 times negative 4, that gives us a positive, plus 1, that's a positive. So this is positive. Negative 3 there is a positive. Negative 3 here is plus 2 is a negative. Positive times negative, negative. The middle part, any number between negative 2 and 1 over 4, I prefer 0. 0, eliminate that to remain with a 1, positive. 0 at positive, so positive. Greater than 1 over 4, you can just think of a simple number 1. Negative 4 plus 1, negative 1 plus 2, positive, negative. So we're interested in the sections that are giving us greater than or equal to 0, greater than. So the middle part, right? The middle part has given us a positive. A positive is one that is greater than 0. So therefore, the values of x that can define our domain should be negative 2, less than x, less than 1 over 4. Now, don't forget that this was actually saying greater than or equal to 0. So the zeros as well included, so add a dash down there. So this is actually the domain. This is a set of values of x that would define that function. Yeah. So that's it for B. Simple and straightforward, right? Yeah. Alright, so we're going to look at question 2. This one is dealing with a bit of functions, as you can see. Alpha, beta roots is the second part. And then we have part dealing with the quadratic function, and then C is dealing with the remainder and the factor theorem. Okay, so let's look at it. Given the functions f of x for the first one, don't mind the way the questions are. Okay, so f of x is equal to x plus 1 over 3x minus 1, and then h of x is equal to x squared minus x. So we are told solve the equation h of f inverse of x being equal to 0. So if we look at this, the two functions that we're able to identify here are, the first one is h itself, so h is maintained, and then the inverse of f. So what we don't have is the inverse of f, so I have to find the inverse of the function of x. So this one. So how do we find the inverse? So the simpler way is let's let the functional part be substituted by y being equal to x plus 1 over 3x minus 1. So our goal here is to try to make x the subject of the formula. And so if I were to cross and multiply, we end up with y multiplying with everything on the denominator there, so that would be 3x minus 1 equal to, the other part remains just x plus 1, and then we're going to have 3xy when we multiply by y, and then is equal to x plus 1. So our goal, remember, is to make x a subject of the formula, and so therefore let every part having x be on the left, so add minus x both sides, so it will be minus x, and then 1 plus y. At this point our goal is to make x a subject, so we can factor out x and then remain with 3y minus 1 is equal to 1 plus y, and so divide both sides by that, you remain with 3y minus 1. At that point we can swap back the y and the x, so we know where there is x, that's where we have the inverse of x, and then where there is the y, we put back our x, so 1 plus x over 3x minus a 1, and so that's our inverse function. Well, sometimes people want to be so sure of what they've done, so I always like giving an example or a way that you can easily actually prove that whatever you've done is actually correct. So how do we do that? So get the original function, let's substitute a 0, right? If we plug in a 0, it means we're going to have 0 plus 1 over 0 minus 1, so end up with negative 1. Let's try to plug in this result, negative 1, into the inverse function, so 1 minus 1 over negative 3 minus 1, that's a 0, over minus 4, so that's a 0. So inverse and the function are supposed to give you the opposites, and that's exactly what you're seeing. So this is actually verified. So we found our inverse function, which is the function of our interest for the first part. So I'm sure they can give you a mark for that. Now they want you to find h of f inverse of x. So what that means is the first part is a function, which is h of x, that is x squared minus x. Now what I want you to do is, where there is x now in this first function, plug in the inverse of the f inverse of x. So therefore this is equivalent to, where there's x, we're putting the inverse of x, f inverse of x, and then subtracting it, of course. So therefore we're going to end up with 1 plus x over 3x minus 1 squared minus 1 plus x over 3x minus 1. Okay. So let's try to simplify what we have. We're going to end up with 1 plus x, I'm feeling lazy to expand, 1 plus x squared over 3x minus 1 squared as well, and then we're subtracting 1 plus x over 3x minus 1. Okay, at the end of the day, don't forget that this is actually equal to a 0, because that's what the equation is saying, that is equal to a 0. So we have several ways of handling this. One would be, but I think the simpler way would be taking this the other side. Okay, so these questions were not solved beforehand, we're solving in real time. So 1 plus x over 3x minus 1. So you can now see what's common, right? So this is common. So what happens if we are to multiply by the reciprocal on both ends, 3x minus 1 and then 1 plus x? So that would mean that even the other side you do the same. Alright, so this and that will divide, this and that will divide, so you have 1 1, and then this one and this one will divide, you remain with just 1, power reduce, equally there the power will cut, it remain with 1 after dividing. So you remain with 1 plus x over 3x minus 1, and then this is equal to a 1, and then again you know where we are now. At this point you can just easily cross and multiply. You have 1 plus x is equal to 3x minus 1, and then 1 plus x, so we can have x minus 3x is equal to negative 1 minus 1, end up with negative 2x is equal to negative 2, therefore x becomes a 1. So how true is that? Is it true? So let's say our x is equal to a 1 and we plug it into what we're having there. So that would be 1 plus 1 squared over 3 minus 1 squared minus 1 plus 1 over 3 minus 1. Would that give us a 0? Is the question at hand. 2 squared over 2 squared minus 2 over 2. So 1 minus 1, yeah, that's true. So our value of x therefore is 1. So we've answered the question, right? So each time understand that whatever we have written first is a function you are going to use, and the second part will be taken as something you can substitute. So if you have something like this, this implies you have something like this, meaning that wherever is x in this function, plug in the other function. Now in this case, it didn't give us an inverse function, so we had to find the inverse of that before we could actually substitute, and then we had to equate it to the 0 as indicated in the question. Alright, so we're now on B. The roots of the equation 2x squared minus x plus 4 is equal to 0 are alpha and beta. Find the quadratic equation with the integer coefficients which has roots, that and that. So straight away, look at the equation they've given you. So the roots are alpha and beta. So there are only two things that come to my mind. Alpha beta represents what? That's the same as c over a, and then alpha plus beta is negative b over a. So our c in the quadratic equation there is what? 4. Our a is 2. And then this other part, our b is a negative 1, so negative 1. And then our a is a 2. So therefore 4 divided by 2 of course is a 2. And then the other side, that's a positive 1 over 2. That's step 1. Step 2 is look at what they've given you as the new roots. So equally they can be added and multiplied. Let's start with multiplication. Alpha plus beta over alpha squared multiplied by alpha plus beta, and then what happens when you multiply these two? Alpha and beta multiplied by alpha and beta, that would be alpha plus beta squared, and then divided by alpha squared multiplied by beta squared. That's after multiplying. Now some of you who are not very new to the alpha and beta, you understand, I've actually labored to explain what this is equivalent to. So of course when you expand that, you're going to have alpha squared plus 2 alpha beta plus beta squared. That's normal expansion. Now every time you're trying to deal with alpha and beta, you want to ensure that everything that you're going to have should be written in the form of alpha beta and alpha plus beta. So this is this is actually this is actually already in the form that we want. I don't know what I was thinking. This is just unnecessary overthinking. All right, so apologies for that. So anyway, just for the sake of you understanding, so in the cases where you can have um, in cases where they're going to give you alpha squared plus beta squared, that would not be in the required form, so you end up subtracting minus 2 alpha beta, so that this is equivalent to what remain on the right, which would be alpha squared plus beta squared. So wherever you see alpha squared plus beta squared, you substitute this part, but in this case we already have it in the required form, which is the addition of alpha and beta. And then for the denominator alpha squared multiplied by beta squared can just be, we can just pull out the square so that it's also in the form of the product. Okay, so at that point we are very much in this form, so we can substitute what we have. Alpha plus beta is half, so that will be half squared divided by alpha beta, which is 2 squared. Now dividing by 2 squared is as good as multiplying by its reciprocal, which is 1 over 2 squared, and so you have 1 over 4 multiplied by 1 over 4, which I'm sure you know gives us what? 1 over 16, right? So at the end of the day, this is basically just equal to 1 over 16. Now we can now look at the addition part. These same two new roots, we're supposed to add them. So we have alpha plus beta over alpha squared plus alpha plus beta over beta squared. Okay, so let's just take note of what we have already. The product, don't forget, it's 1 over 16. Okay, so this other part which we are adding, common denominator, the product of the denominators will be alpha squared beta squared. Let me just write that better. So we have alpha squared plus beta, or when they multiply it, it's alpha squared and then beta squared. Divide by this, it will give us beta squared times what's on top, so that will be beta squared multiplied by alpha plus beta, and then plus, if you divide by beta squared, you're going to have alpha squared multiplied by alpha plus beta as well. Okay, so this is the addition. Now it's not already in that form, so you can just go on and actually try to expand. So beta squared times alpha, that's going to be alpha beta squared plus beta cubed plus alpha cubed, and then we have beta of alpha squared over alpha squared and then beta squared. Okay, so at this point some of you are already intimidated, like, oh, what's happening here, what's going on? So don't forget, this is actually dealing with addition. Now how do we handle this? So this part that you can see here is a part that's giving us issues already, right? Because it's not in the form of alpha beta and the addition. So we can use the quadratic we can use binomial actually. So we have alpha cubed plus beta cubed. How do we expand that? Okay, so before we try to find a way in which we can actually represent that, let's now picture it in a cases where we can have alpha plus beta to the power 3. Expand that, because that's the one that is going to produce such a result. So I can give you two ways of handling this. I have a binomial. I think in the other video I've talked about binomial. So in this case You can use any other method that you want. Okay, so if you are to use binomial, you want a case where alpha and beta are going to be to the power 3, right? So obviously that's going to be a term. Since this is raised to the power 3, that would be the term, that should be the third term, right? So the third term, which is going to be alpha, what term would be that actually? Would that be the third term? I don't think so, because the third term is going to be 3 minus 3 and then beta to the power 3, so it wouldn't actually add up. I think let me show you the other route instead. Let me show you the other route. So the other route is, I told you to say alpha plus beta squared. This can easily be expanded, and then you multiply by alpha, multiply by beta, right? So alpha plus beta squared is something like alpha squared plus 2 alpha beta plus beta squared. So you know that already. So multiply by alpha beta, you'll be able to get what we are looking for, right? Okay, but that's too much of work, and so let me get you back to a binomial. So if I use binomial, we know of the triangle as well. So if you're new to the triangle or the Pascal's triangle, please check it out. Look it up on our channel, and even on our site we do have videos about that. So this is for a first expansion, this is for a second expansion, and this is for a third expansion. So we're interested in the third expansion, right? So which is 1 3 3 1, right? And so if you had to use the binomial theorem, alpha plus beta cubed, so you're supposed to start from the first expansion, unlike what I was trying to show you at first. So you say 3 0, write the first term, that would be alpha cubed, beta to the power 0, plus just and so on and so forth until you get to the last part. But for the triangle, it's actually faster. So these are your coefficients, and then don't forget that what you're trying to expand is alpha plus beta to the third power. And so if you have 1 3 3 and 1, what that means is you're going to have, for the first part, of course, which is a 1, you're going to have 1, and then alpha will be the maximum power, and then beta will be the power 0, so we don't have to indicate it. For the second part, where we have 3, don't forget the coefficients. So the coefficients are 1 3 3 and 1. So for the second one, we've got a 3, so it will be 3, and then alpha will reduce the power 2, so it will be alpha squared. Beta will now be the power 1, and then we're going to have, for the second one, alpha will be the power 1, beta will be the power 2, and then lastly alpha will be the power 0, so we just end up with beta to the power 3. And so that's what we have at this point. So if we try to simplify that, don't forget this is 1 over 16. So we have alpha cubed, I get the last part beta cubed, and then the middle part we have 3 alpha squared beta plus 3 alpha beta squared. Now this is equal to alpha plus beta raised to the power 3. So our goal is to make the alpha, this first part, the subject. So if we do make it the subject, it's actually going to be equal to what's on the right, alpha plus beta raised to the power 3 minus these parts. So that is 3 alpha squared beta plus 3 alpha beta squared. It's actually also supposed to be subtracted. Everything has gone to the right hand side. So that's what this is equal to. And so now at liberty of now substituting in the expression that we had. So where there's that, we'll have to put that. So if I start from this side, first of all we have alpha beta squared. Now the middle part is going to be plus alpha plus beta to the power 3 minus 3 alpha squared beta minus 3 alpha beta squared and then the last part is plus beta alpha squared, right? So plus beta alpha squared over alpha squared beta squared. So which parts are still not appearing in the form that we require, which is the product and also the addition? So the first part, alpha beta squared, which is of course like terms with that part, and so if we subtract, we're going to remain with a minus 2, right? Since that one was positive, so that would be a minus 2. And then the other part, beta alpha squared, as well, these are like terms with that, so as well it will become minus 2 now, so that we just remove that part. So we make it a little bit clean. So 2 2. So is there a way that we can actually express this in the form of a product or addition of alpha and beta? So if we try to factorize what's common, if I start with the first part, we have alpha plus beta raised to the power 3, and then minus 2 of course is common, and then alpha is common, beta is common. For the first part you remain with beta, sorry, with alpha, and then the second part you remain with beta. So you see that everything is now in the form. The denominator can be expressed as pulling out the square. So at this point everything is now expressed in the form of product or addition of alpha and beta. And so alpha and beta is what? Is half. So we're going to have half to the power 3 minus 2 alpha beta, which is a 2, and then alpha plus beta is what? Is half, and then this is all to be divided by the product, which is 2 squared. Well, this is equivalent to 1 over 8 minus 2 times 2 is 4. 4 divided by 2 is 2 over 4. Now if you subtract 1 over 8 minus 2, 8 times 2 is negative 16. So 1 minus 16 is just negative 15 over 8. Divided by 4 is as good as multiplying by 1 over 4. Then 4 times 8 is 32. So we have something like negative 15 over 32. If our simplifications are right. What are we saying so far? So for the addition of our new roots, addition gave us 1 over 16. Now, sorry, the product. Product gave us 1 over 16, which we know the product is equal to C over A. And then the addition, so this is actually the product. And then the addition has given us negative 15 over 32, which we know that the addition is actually equal to alpha plus beta, which is equal to negative b over a. So every time you're trying to, before you try to find a, b, c, you're supposed to ensure, since a is actually common every time. So for us to make 1632, multiply both sides, both the numerator and the denominator, by a 2, right? So you end up with 2 over 32 is equal to c over a. And so clearly a becomes a becomes 32, and then our b, since negative b is equal to negative 15, they will cancel out, b becomes positive 15, and then our c is basically equal to a 2. So therefore, if I were to write down our equation with these roots, that would be 32x squared plus 15x plus 2. So that's how you handle question 2a. As simple as that sounds, right? Alright, so we're now on question b, which is dealing with quadratic functions. So express a function, that function, in this form. So there are two ways of handling this question. One is to complete the square, and then the other one, of course, is just by expanding that and then equating it to that to find the values of a, p, and q. So we'll go by computing the square. So let me start with negative 3x squared, and then minus 14, or actually let's go to actually the x part. So plus 12x and then minus 14 equal to 0. So to complete the square, we have to ensure that the coefficient of x squared is a positive one. So we can factorize negative 3, you remain with x squared minus 4x, and then that's going to give you a positive 14. Since we can't divide, we'll just write it negative 14 over 3. Okay, the idea is after factorization, whatever you have outside there, if you multiply whatever is inside, it should give you the original part. Okay, hope we're good there. So let's forget about negative 3 for a while. We have x squared minus 4x plus 14 over 3. So at this point, let's have a constant b on the other side. And so if a constant b goes the other side, or we subtract both sides by minus 14 over 3, we're going to have a minus 14 over 3 on the other side. So let's add both sides the half of the middle part, which is minus 4. So we'll add minus 2 squared, that's a half both sides. The half of b is negative 2. So completing the square, let's get the parts that are having the square. So we're going to have x minus 2 raised to the power 2, and then equal to negative 14 over 3 plus a 4. So 4 minus 14 over 3. 3 times 4 is 12, minus 14 over 3. That's a minus 2 over 3. So on the right hand side, after simplifying, we should get a minus 2 over 3. Okay, we can have it back the other side. You're going to have x minus 2 squared plus 2 over 3. This is equal to 0. Let's bring back our minus 3 that we had actually pulled out. Okay, so whatever we're going to have after multiplying by minus 3 is actually the wanted solution. So you're going to have, remember it's like a 1 there, so we're going to have negative 3, and then this part, the 3 on the bottom will actually cancel out, so that you just basically remain with a 2, right? Negative 2 equal to 0. Hope my calculations are okay. Negative 3 multiplied by 2 over 3, negative 2. So we've computed the square. Our a is -3, our p is -2, our q is -2. The first part is done, 3 marks. Now I have to sketch a graph. Okay, so to sketch a graph is actually easier. Our x in the brackets is equal to x minus 2. X minus 2 equated to 0, you're going to have x is equal to 2. Then this part is your c. Okay, so that's your y value, -2. So meaning that you have 2 comma -2. You can actually try this. X is equal to -b over 2a. Our b is -12. And then our a is 3, -3. That's going to be -6, that's 2. Now whatever you get as a 2, plug in the original function, you should get -2 as well. Alright, so that's our turning point from the result of this computing the square. So we want us to show the turning point and also the points where the graph crosses the coordinate axis. So we found the turning point. The other part that we can find is this value in the original function, a constant, our c, that's our y-intercept. So we just need to find the x-intercepts where this function is equal to 0. So that's basically simple. -3 is equal to 2, and then what do we do? And then divide both sides by -3. So I can actually foresee this, that this basically it's not possible for us to find the x-intercepts, and so we can just sketch. The turning point is 2, -2. So 2, -2. So I have to draw the graph a bit smarter. I've already predicted the outcome. So let's move this other side. Okay, so 2, -2. So that's the turning point. The x of y-intercept, we said it's -14. So let's say somewhere there. Now the smarter way is actually not even to show it and then just draw the graph like this. And then you just cut there to say that's -14. And then clearly show that where it's turning from, and that's the turning point. So 2, -2. So you can actually see the reason why I said it's not possible for us to have the x-intercepts, because the graph is having a maximum point below the x-axis. So that's why I actually saw that if you had to try to find the values of x like this, when you divide by -3, you're going to have a negative on the other side, so you can't find the square root of a negative number. So it's actually, we don't have real roots for this quadratic function, and so that's where question B ends with your 6 marks. Alright, so we are now on question C. We're dealing with the first part is dealing with of course these are polynomials. Now we're dealing first of all with the remainder and the factor theorem, and then we'll deal with factorization of the polynomial. Okay, C1, given that x plus 3 is a factor of a cubic function, so a cubic function is h of x, is equal to x to the power 3 plus ax squared minus 2x plus b. So what is our cubic function? Now, given that x plus 3 is a factor, so just that first part can give us an equation. Given that x plus 3 is a factor, take note of that. X plus 3 is a factor. And then that h of x gives a remainder of 10 when divided by. So if it's a factor, the remainder is 0. And then for the other one, which is x minus 2, we are told the remainder is 10. Find the values of the constants a and b. So just come up with two equations using the two conditions given. You are good to go. The first condition, we are told x plus 3 is a factor, the remainder is equal to 0. So if you are trying to equate this to 0, x is basically equal to negative 3. In the other part, x is equal to 2. So using that value, if we are told it is a remainder, if we are told it's a factor, meaning that if we are to plug in negative 3 in the function, it's supposed to be equal to a 0. So that's what the remainder factor theorem tells us. So let's try to plug in the negative 3. So negative 3 to the power 3 plus a negative 3 squared minus 2 negative 3 plus b. That should be equal to a 0 since it's a remainder. Since it's a factor, I apologize for that. So negative 3 to the power 3, that's negative 3 times 3 is a positive 9 times 3 is negative 27 plus 9a plus 6 plus b equal to 0. Negative 27 plus 6 is a minus 21. So we have 9a plus b with a positive 21 after adding both sides by positive 21. Okay, so this and that gave us a minus 21, and then becomes positive on the right hand side. So we've come up with the first simple linear equation. Let's now focus on the second part. Here we've said x minus 2 gives a remainder of a 10. So if we substitute a 2, we should be able to get a 10. So let's do that. 2 to the power 3 plus a to the power 2 minus 2 plus b is equal to 10. So where there's x, that's where we are putting that. So what we have, we've got 8 plus 4a minus 4 plus b is equal to 10. And then we end up with 4a plus b. 8 minus 4 is a 4 equal to 10. So we have 4a plus b. 10 minus 4 is a 6, right? So these two equations are enough. The first simple one can just be make b the subject, so b is going to be 6 minus 4a. Then we'll substitute in the other equation, which is 9a plus our b is equal to that. So that would be 6 minus 4a, and then is equal to 21. So 9a minus 4a is 5a. 21 minus 6. 21 minus 6 is what? That would be a 15. So 5a is equal to 15. And then a is equal to 3. So that's after substituting the other equation. So if we get back to our b, where b is the subject, 6 minus 4 times a. So 4 times 3 is 12. 6 minus 12 is a minus 6. So we found the values, right? Therefore, our a, if all our computations are fine, our b, that's it for the first part. And then now for the last one, under C, factorize the cubic function. So this is now where we use the try and error method, because Up to this time, nobody's up to this is 2024. Up to this time, no one has actually discovered a direct method of finding a factor of a cubic function other than trying to guess. So what value can we substitute in this equation to give us a 0? So I usually like working with, first of all, -1, 1, -2, and then 2, and then sometimes also include half and -half. So for most of the exam questions, I usually like working with these. So let's start. So if I were to plug in a -1, here the sign would actually change, and there it would change. So let's try to see. Let's try a -1. -1, it would remain a negative. Here it would become a positive. There it would remain a negative. So we're going to have 3, not 3. So +2 -7 +4 +4. This is a -5. Of course, this is not giving us a 0. So -1, as we refused, try a 1. Everything remains as they are, just ignore x. Of course not. That's a -9. Let's try a 2. -2 to the power 3, that's 8. -7 to the power 2, that's a 4. This is a -16. That's a -28. That's a -8. This is a 4. -16 minus 8 is a -24. -28 plus a 4. Oh, there's nothing positive here. Nah, okay, so this has refused. Well, it seems like if we had to use a positive one, things are going to work here. If we're going to use a -1, so if you use a -1, this would be a -8. This will remain still positive. This will be a negative. So this will be +16. That will be a -28. This will be +8. That will be +4. This looks close. 16 plus 4 is 20. Yeah, this 16 plus that 4 is 20. -28 plus 8 is a -20. So this has worked. It's a 0. So therefore, x is equal to -2 has worked. So if you're writing it in terms of a factor, I would say x plus 2 is a factor. So there are two ways. You can use a long division, you can use synthetic division, whichever you're comfortable with, to find the other factors. Let me use synthetic division. It's been a while since I used synthetic division. So x is equal to -2, so we'll use -2. And then we'll grab the factors, the coefficients, sorry. So the coefficients are -2, -7, -4, and 4. Each time you're trying to use synthetic division or in actually division, ensure that the powers are increasing in the normal order: 3, 2, 1, 0. If there's a missing power, let's say there was no x squared, we would have added a 0 where there's -7 to just represent that part. Okay, so first step, drop the first coefficient. Now we'll be multiplying with our factor, -2 times -2 will be a 4. -7 plus 4 is a -3. That would be -2 by -3. That will give us a +6. That's a +2. That's a -4, 0. That's a remainder 0, indicating this is a factor. Now x to the power 3, so it now reduce to be x to the power 2, x and then a 0. So we have a quadratic function which is 2x squared minus 3x plus 2. So far it's something that is looking like x plus 2 like this. This is how far we factorize. Now we have to factorize completely. So, well, it's still possible to factorize a quadratic. Let's look at it. The product in this quadratic is a 4. The sum is a minus 3. What two numbers can you multiply to give us a 4? We add them, they give us a minus 3. I think negative 4 and 1. Well, that would give us... Well, not precisely, because that would give us a negative 4 instead. Okay, this looks a bit odd when I thought it would. Let's look at it again. I hope I got the right equation. So, oh yeah, so this is actually negative. That's why it's messed up. So the product is minus 4. The sum is negative 3. The factors negative 4 and a 1. So we're going to have negative 2x squared minus 4x plus x plus 2. Up to now, I think everybody knows how to factorize at this point. So we haven't yet factorized this part. So put a minus 2. Actually minus 2 of x, so that you remain with a positive x and then a positive 2. Pour out a 1, you have x plus 2. So I can start now with the 1 instead of the minus 2x. I can say 1 minus 2x, and then I can say x plus 2, which is common, and then I can also get back this part, which was x plus 2 equal to 0. So we factorize completely. We don't have anything that we can still factorize. We have factorized completely. And so that's it for question C. Alright, so we're now on the third question of the paper. And so now we have to solve the radical equation and also solve the modulus inequality, absolute value equation, and some other questions. So let's start with the first one. The first one is solve the radical equation, and what we have is 3 plus the root of x plus 6 is equal to the root of 11 minus x. So how do we handle such a question? So it's put in a state where we can easily square both sides, right? That's what we basically tend to do when we're dealing with radical equations. So let's just square the left and the right. Okay, so now when you square both sides, you understand that if you've got the power to it, implies you're multiplying the brackets by themselves, right? So assume we've got a 3 outside. So 3 plus root of x plus 6, again multiplied by 3 plus root of x plus 6, and then all these are in brackets, and then that is equal to the root of 11 minus x multiplied by the root of 11 minus x. Okay, so basically get the first of all the first 3 there and then multiply by the other part, right? So 3 times that, we're going to have a 3. 3 times 3 is a 9, and then plus 3 root of x plus 6, right? And then for the other part, this times that again will be plus 3 root of x plus 6, and then finally this part and that part. So whenever you're multiplying the square roots by each other, what basically happens, the result is they cancel out, so that you just remain with what is inside or under the brackets or under the square root actually, sorry. So that's just x plus 6. Okay, the idea is very simple. Root of 2 by root of 2. Square roots indicate half, and so half multiply by, add half plus half, because this is like same bases, and then adding half gives us just the 1, so it basically disappears. Okay, so on the other side the same concept applies, so the square root will disappear, so you just have 11 minus x. Okay, do we have any like terms here? We do. So 9 plus 6 is a 15, then 3 plus 3, that's a 6, root of x plus 6, and what else is remaining, and then plus x. This can come the other side, right? Or we can actually just leave it the other side, but we can, let's see, is equal to 11 minus x. We can leave it the other side. Now you can see there's still an existence of a square root somewhere, so want to get to a point where only this remains on a single side, so that if we square it, it will disappear. So let's leave it on the left. So we have 6 root of x plus 6, and then equal to the other side we have 11 minus x. Now this part, if it goes outside, it will be minus 15, and then that will be minus x. So 11 minus 15, these are like terms, that gives us a minus 4, and then negative x minus x is a minus 2x. So basically this can just move. That's the result after collecting like terms. And at this point we're at liberty now of squaring both sides again. So after you do that, you are going to notice that we're going to remain with 6 times 6, 36. The root multiplied by itself will definitely disappear, so we're going to remain with x plus 6 is equal to negative 4 times negative 4. I believe you understand that that's the same as multiplying by itself twice, right? So negative 4 multiplied by negative 4, that's 16. Negative 4 by minus 2x is plus 8x, right? And then again negative 2x by negative 4 is positive 8x, and then negative 2x by negative 2x is positive 4x squared. Okay, quite interesting, right? So let's collect the right terms. 36 is multiplying with whatever is in the brackets, right? So 36x multiplied by again 6, 36 times 6, okay, which if you try to multiply 36 by 6, 6 times 6 is 36, 6 times 3 is 18, plus 3, 21, so that is 216. Is equal to 16, 8x plus 8x is also 16x plus 4x squared. Now at this point you can see that you can easily come up with a quadratic equation, right, by correcting everything on a single side. So let me start by writing 4x squared and then plus 16x. So 16x, if you move this other side, it will be minus 36x. I'm collecting the right terms in advance, and then plus 16 minus the 216 from the other side, so you can have a 0 there. So all we're just solving here is now the quadratic function. So we're going to have 4x squared. 16 minus 36 is a minus, should be minus 20, right? So that's a minus 20x. And then 16 minus 216 is a minus 200. Is it a minus or a positive? It's a minus. Minus. Because on the other side it was a positive value, so it is negative. So we have a minus 200. And that is equal to 0. Okay. So now at liberty of simplifying this. Okay. So you can use any method of your choice to handle this question. Okay. So if you have to think of it, try to factor out what you think is common here. So I think 4 is common, and then we can remain with x squared minus 5x, and then that's a minus 50 is equal to 0. Now try to factorize what is inside there. So the product is minus 50, the sum is minus 5. What two numbers can you multiply to give you 50? You add them, they give you a minus 5. Any possible numbers? What do you think of 5 and 10? 5 and 10. Which one is negative and which one is going to be positive? So if you make 10 to be the negative, 5 times negative 10 is minus 50. Negative 10 plus a 5 is a minus 5, right? Okay, that looks fine. So we're going to have 4, and then in the brackets we're going to have, since we've got a coefficient of 1 there, you don't have to necessarily do the normal factorization, it's a sheer waste of time. You're just basically going to have x plus 5, x minus 10 equal to 0. So x is equal to negative 5, x is equal to 10. Okay? So these are the two possible solutions that we can have. And we don't just end there, we have to try. We have to try them out. So let's get back to our radical equation. And then let's try just to plug in negative 5. So for negative 5, we've got 3 plus negative 5 plus 6, and then 11 minus negative 5. So we have 3 plus negative 5 plus 6 is a 1, so root of 1 is a 1, and then the other side 11 plus 5 is going to be a 16, so root of 16. So you can agree that 4 is equal to 4. So x is equal to negative 5 is actually a solution. You can apply the same concept and try out substituting 10. So 10 plus 6, 11 minus 10, 3 plus 4 cannot be equal to 1. So this is not a solution. So we discard that one and only remain with x equal to negative 5 as the only possible solution to our radical equation. And that's how easily you can handle a radical equation. Alright, so we'll now try to solve the modulus inequality. So we have 16 minus x squared, and then greater than 2x plus 8. So just to help you understand what the modulus mean, it means whatever result you have, whether positive or negative, it should become positive. So if you're going to have the modulus of negative 6, the result is 6. The modulus of positive 6, the result is 6. That's what it implies. So now using that very idea, we can't really work with the modulus in an equation when you're trying to solve it. So we can instead introduce brackets and then place plus or minus. Okay? So what that means is we don't basically care whether it's negative or positive. At the end of the day, if it was going to be outside, it was going to be positive. So the positive or minus, when can it be greater than 2x plus 8? Okay, so we've got two possible cases, and so we should try to account for both. So if the two inequalities that are going to be a result of this are going to be, the one with a positive will be 16 minus x squared as there is, greater than 2x plus 8. Then the other inequality, the other side, is going to be distributing the negative. We're going to have a minus 16 plus x squared greater than 2x plus 8. Okay, so I believe you know how to handle solve inequalities faster and simpler, right? So with what we have, we can just form quadratic on one end so that we come up with a quadratic inequality. So for the first part, we're going to have a minus x squared, and then this will now become negative 2x, and then the 16 is still there, and then minus 8 greater than 0. Then you end up with negative x squared minus 2x plus 8 greater than 0. So quadratic inequalities are easily faster simplified if you deal with them in terms of working with factorization. So let's try to factorize what we have and see the outcome. So we have the product minus 8, the sum negative 2. What are the two factors? Think of 4 and 2. Which one should be negative and which one should be positive? Well, if we're to make it positive 4 or negative 4, that is going to work. So negative x squared minus 4x plus 2x plus 8. And then we try to factorize that. So we've brought a negative x for the first part. We're going to remain with positive x minus, that's going to be now positive as well, positive 4. And then if we put a 2 there, we're going to have x plus 4 as well. And then this is greater than 0. So it's getting more and more interesting. So now the two results we have are negative x plus 2, if you get that negative x and the 2, and in the brackets you have x plus 4. This is all greater than 0. So how do we solve the inequality in itself? So the two zeros that we have of the equation are simple and straightforward, right? If you equate this to 0, that's going to be x is equal to 2, and then if you equate this to 0, it's going to be x is equal to negative 4. So we can actually come up with a table to just help us come up with solutions there. Okay, so we've got negative 4 and 2. Let's try to work on the other side so that we just combine everything on a single table to make things faster. Alright. So what we have, negative 16 plus x squared minus 2x minus 8 greater than 0. We end up with x squared minus 2x. Negative 16 minus 8 gives us a minus 24. That's greater than 0. Equally, there we can try to factorize. The positive, the product is a minus 24. The sum is a minus 2. So think of two numbers. 6 times 4 gives us 24. Now which one should be negative? Since the sum is negative, let the bigger number be a negative. Negative 6 times 4 is minus 24. If you add, it's a minus 2. So since the coefficient of x squared is a positive 1, this is simple. So it will just be x minus 6, x plus 4. We're just adding the factors, and then greater than 0. So we can easily now come up with a table, right? So let me just move this a bit up. Okay, so this a bit up, and then this other part. Just there. And then there we've got x is equal to 6. There x is equal to negative 4. So you can see negative 4 is actually common. And then how many things do we have? We've got negative x plus 2, x plus 4, x minus 6. So x plus 4 is actually repeated twice, if you can actually see. So the table will actually be very simple. So we're just going to have negative x plus 2, and then x plus 4, and then we have x minus 6. Okay, so we can draw a table. So what do we have for the tables? So which one do you think is the smallest number among the numbers that we have? So negative 4 is the smallest, so we can have negative 4, and then we can have 2, and then we can have 6. Okay, so then we can draw lines here. So these are the zeros to the inequalities. Now our goal is to try to determine the sign if we are to get any section. So negative 4, it implies going this side. These are numbers that are less than negative 4. These are numbers between negative 4 and 2. These are numbers between 2 and 6. And these are numbers greater than 6. So I want to see if you're able to agree with the inequalities that we actually have here. Okay, so let's try to plug in. Think of a number that is less than negative 4. So I can think of negative 5. Now let's try to plug in into these we see. Plug in negative 5 here. So that would be positive 5 plus 2. So that would be a positive. Plug in negative 5 here to be a negative 1. Plug in negative 5 here to give us a negative number. Then the other side, think of a number between a negative 4 and a 2. So the fact that we're transitioning from a negative number to a positive, I can just easily think of a 0. If you plug in a 0 for the first part, it will be positive, positive, negative. Then the other part, between 2 and 6, think of a smaller number, a smallest number possible. Think of a 3. So if you think of a 3, negative 3 plus 2, that's a negative. 3 plus 4, that's a positive. 3 minus 6 is a negative. Okay, and so then we can actually try out now to see what is the possible outcome. So for the first part, positive, negative, negative, right? So if you multiply them, what is the result? So that's a positive result. For the middle part, positive times positive, positive, negative, negative, positive, positive, that's also a positive result. And so since we're looking for the cases where our inequality is greater than 0, it implies we're interested in the positive results. And so that's including numbers less than -4, and also the numbers that are between 2 and 6. Well, we haven't tried one more case, that's the numbers greater than 6. Let's think of a 7. If we plug in 7 for a first part, -7 plus 2 is a negative, the other part will be positive, and then the last part will be positive. So that will give us a negative, so we still remain with two cases. So the two cases are numbers less than -4, so that is x is less than -4, and then numbers that are between 2 and 6. Okay, so this is exactly what we're trying to say. That's our solution set, and you can actually present it using the set interval notation by saying our solution set are numbers from -infinity up to -4, and then of course combined with numbers from 2 to 6. Okay, so that is a solution set to our modulus inequality. Okay, now with that understanding, we can apply the same concept to answer this simple absolute value equation. The modulus of 3x plus 4 is equal to 2 minus x. So when you see the moduli there, what you're trying to say is introduce plus or minus of 3x plus 4, and then is equal to 2 minus x. So the two possible equations or results are the positive one, 3x plus 4, is equal to 2 minus x. The other one is distribute the negative. So we have 3x plus x when you correct the like terms, and then 2 minus 4, end up with 4x is equal to -2. Divide by 4, x is equal to -2 over 4, which is -half. The other part, we've got -3x plus x is equal to 2 plus 4. So -2x is equal to 6. X is equal to -3. So these are the two possible solutions. And you can actually try them out of curiosity. So if you plug in 3 times -half plus 4, you end up with -3 over 2 plus 4. So is that going to be 2 minus half? Let's do something better. If you plug in -half and then 2 minus -half, so 3 times that is going to be -3 over 2 plus 4, and that's going to be 2 plus half. So 4 minus 3 over 2, the secret there is just the shortcut is 2 times 4, that's 8. So -3 plus 8 is a -5 over 2. The moduli of course gives us a positive result. The other side, 2 times 2 is 4 plus 1, 5 over 2 as well. So this is actually true for the half, -half. And if you try -3, you probably expect it to be the same as well. 3, -3 plus 4. This is going to be -9 plus 4. That's going to be -5. That's +5. So true. So both cases are true. So these are the two solutions to B1. Alright, so let's solve the rational inequality. Okay, so we've got x over x squared minus 4, and then less than 1 over x plus 3. So we can have this be on the other side, -1 over x plus 3. So we'll have a 0 now on the right hand side. So what do we do now? We can just combine this, that we come up with a common denominator, right? So we have x, this is x squared minus 4, right? So x squared minus 4, and then we have x plus 3, I wish I can go with a difference of 2 squares, but I don't want to complicate things. Don't want to expand it. So if we divide that into what we have, we're going to have x plus 3. So we have x multiplied by x plus 3 minus, again, this, if we divide, we're going to have that. So it will be a minus 1 on top multiplied by x squared minus 4. This is ought to be less than 0. And if you try to expand there, we're going to have x squared plus 3x minus x squared plus 4. So that's just on the numerator, and then divided by x squared minus 4, and then we have x plus 3. So any like terms, this and that can subtract, and then essentially what remains on top will just be 3x plus 4 divided by x squared minus 4, and then our x plus 3. This is less than 0. Okay, so we can now try to find the two zeros to the equation that we have. So the first 0 is the numerator equated to 0. 3x plus 4 is equal to 0. 3x is equal to negative 4. And then x is equal to negative 4 over 3. That's for the first part. The other part, we have this equated to 0. X squared minus 4 is equal to 0. X squared is equal to 4. So x is equal to the square root of 4. So that's plus or minus the square root of 4, which will just be 2, plus or minus of 2. And then if you equate the x plus 3, it's going to be x is equal to negative 3. So these are the different values that we have. And then in terms of distribution, since these are three things, are they three? Yeah, there are three things actually. So we have 3x plus 4, and then the x squared minus 4. We understand that even if we were to expand it, it's going to turn out to be a difference of 2 squares, right? But let's just take it as 1. That's also fine. X squared minus 4. And then we can also have x plus 3. So if you want, you can expand this and come up with four brackets. That's also fine. But we'll just work with this. So don't forget, we have x is plus or minus of 2. So which one is the smallest number between negative 4, negative 2, and negative 3? I think negative 3 is the smallest. So negative 3, and then followed by negative 2, and then followed by negative 4 over 3, and then followed by positive 2. And then you can draw lines on these possible zeros and asymptotes. So think of any number that is less than negative 3. You can easily think of negative 4. So if you plug in where there is x, that's going to be a minus 12, which will be bigger than 4, so negative. If you plug in there minus 4, it's going to be 16, positive 16, minus 4, that will be positive. And then on the bottom, negative 4 plus 3 is going to be a negative. If you got the middle part, any number between negative 3 and the minus 2 that you can actually think of. Any number that you can think of. Well, that would be something like a fraction, right? Because negative 3 and a minus 2. So maybe a negative 2.5 is a number in between. So if you plug in for this part, negative 2.5 times that is going to be greater than 4. So that would be a negative. Well, if you plug in there, if you square that, it's definitely going to be greater than 4. So it is going to be positive. And then if you plug in there, it's going to be less than 3, so it's going to be a positive as well. Think of a number between negative 2 and negative 4 over 3. For you to understand, divide negative 4 by 3, that would be negative 1, carry 1 over 3. So actually, that becomes even more interesting, because if we've got negative 2, and then we've got negative 1, 1 over 3, what number can we think of that is likely to be, I think you can think of it, if you think of it in decimals, it's going to be better. So 3 into 4, that's going to be 1, carry 1, so that would be 1.3 something, negative 1.3 something. So if you think of negative 1.5, it's actually in between. So negative 1.5 is a better option. So negative 1.5, if you try for the first part, negative 1.5 times 3, that's likely to be 4.5 or something like that. So that's going to be a negative for the first part. And then if you try that, since it's less than 2, it can be greater than 4, so this is still going to be a negative. And then if you try in 2x plus 3, it's a positive. Now try between, this is easier, transitioning from negative to positive, just think of a 0. For the first part, it will just be positive 4, negative 4, positive 3. And then after 2, think of a 3. Plug in a 3 there. Positive. There to be 9, so positive. There, positive. Everything is positive for the other part. Okay? And then if you try to now multiply these signs, negative, positive is negative, times negative, positive. Negative times positive, negative times positive, negative. Negative times negative, positive times positive, positive. Positive times negative, negative. Negative times positive, negative. Positive. Okay. Now for this question, if you try to look at what we have, our interest was to find the solutions that will make it to be less than 0. I think I needed to leave that there. So what are the possible combinations that can give us values that are less than 0? So implying that we're interested in the negative results. So this part and that part. So numbers between negative 3 and negative 2, since it's coming between here, and then also between negative 4 over 3 to 2. So we're not using these brackets because there wasn't an equal sign. If it was equal to, would have used those brackets. So that's a possible solution set for that rational inequality, as simple as that looks. Now we're asked to sketch a very a very basic absolute value function. Okay, so you've got a negative outside the absolute value, so it's a must every result is going to be a negative, right? So the maximum this function can go is a 4, right? So come up with very simple basic table of values. Okay, so our equation is 4 minus 2x plus 6. That's our y. So at what point do we expect this graph to cut the x-axis? That is where y is equal to 0. We don't want to complicate things. Let's find the y-intercept in short, where x is equal to 0. So y is going to be 4 minus, wherever is x is equal to 0, and then you're going to have 4 minus, that's eliminated, minus 6. So that's negative 2. That's our y-intercept. So it's going to cut the y at negative 2. Now, as it goes towards the right hand side, where does it reach when x is equal to 1? When x is equal to 1, that's going to be 4 minus 1 times 2 is 2, 2 plus 6 is 8. So that's a negative 4. Right? Negative 4. And then if you try 2, as you might guess, it's going to be getting down and down. So that's going to be 2 times 2, that would be 4, plus 6, that would be 12. No, 2 times 2 is 4, 4 plus 6 is 10, so that would be a 10. 4 minus 10 is going to be a minus 6. So it will be getting down and down. And then if you try to go the other side, try negative 1. If you try negative 1, two multiplied by negative 1 plus 6, so that's going to be 4 minus, this is going to be, that's going to be minus what? Why do I feel like I've made a mistake somewhere? No, no, no. So we're actually dealing with a positive, so that's actually very fine. So now we've gone to the negatives. So this is where now the moduli will apply. So that's going to be 2 times negative 1 is going to be a minus 2 plus a 6. And then we've got 4 minus, that's going to be still positive 4. So that would be a 0 actually. So that's a point where it's going to cut the x-axis. And then if we, as we try increasing, let's see negative 2. If we plug in negative 2 there, it's going to be a minus 4. Minus 4 plus 6 is going to be a 2, still 2. And then 4 minus 2 is going to just be a 2. So it will still be going up. If we reach negative 3, that's going to be a negative 6 plus 6. And then that's going to be a 0. So that would be a maximum point of a 4. Okay. So 4, this is a 2. This is at a point, negative 3. And then after that point, it is expected to start coming down. So if you try positive negative 4, that's going to be a minus 8 plus 6. That's going to be negative 2. Yeah, negative 2. And then a modular of negative 2 obviously is going to be positive. So 4 minus 2, that's going to be a 2. So it will start coming down. So this is the way it's basically going to come out, something like this. So just like I'd approximated, so if, the highest point is this because of this negative, and where it's occurring is it's at a point where our x is basically equal to negative what? 3. Okay. So if you continue actually trying to solve it, I can actually see if you try negative 5, so you can actually find even the other point there. That's at the point where y is equal to 0. Yeah. So this is basically the way you expect this sketching to come out. And in the first or simplest way that you can actually sketch this is by coming up with a table of values where you say, okay, let's have x and y. let's have the numbers up to maybe -3, -2, -1, 0, 1, 2, and 3, and just try to find the values of y, and then try to sketch roughly. Okay, so you'll be able to see the y values and you'll be able to sketch. Yeah, and this basically applies to every simple graph that they may ask you to sketch. This is the shortcut you can actually use. I just hope this was helpful for this question, and this is where this question ends. Now let's try to look at the other questions where we try to sketch the rational function. Alright, so let's sketch a graph of this rational function. So rational function, in that it's a fraction, so the function we have is f of x is equal to 10 minus 3x minus x squared as the denominator, and then the numerator we just have a 20. So you can clearly see that this is actually a bottom heavy rational function. So in such a case, just know that the horizontal asymptote is 0. So that's y is equal to 0, which is the x-axis, right? That's a horizontal asymptote for a function which has got a high degree on the denominator, implying that the power of x on the denominator is higher than that of the numerator. That's what you need to know. And then the denominator, at the point where the denominator is itself is equal to 0, that's the vertical asymptote. Because remember, for a rational function, it's you can't determine values where you divide by 0. You can't divide by 0, in other terms. That's what I'm trying to say. So if we try to make a move, we have minus x squared minus 3x plus a 10 is equal to 0. So I've just rearranged that, and then let's try to factorize this. So product is a minus 10, the sum is a minus 3. What two numbers can you think of? If you multiply them, they give you 10. If you add them, they give you 3. I'm thinking of 5 and 2. Which one should be negative? Negative 5 and 2. So therefore we have negative x squared minus 5x plus 2x, and then plus 10. We can factor out what's common. I think negative x is, so remain with positive x plus 5 plus 2x plus 5, and then remain with 2 minus x. I've started with this 2 deliberately. I don't want to begin with a negative. It's okay any way you do it. X plus 5 is equal to 0. So the two values of x that can make, by the way, you can solve it using any method that can make this denominator to be equal to 0 are, equate this to 0, negative x, 2 minus x is equal to 0, and then x plus 5 is equal to 0. So this one is negative x is equal to negative 2, which if you divide by negative both sides, x becomes 2. That one is x equal to negative 5. So these two are the vertical asymptotes. So you can actually sketch by just these two. So let's try to sketch this. Let's say that's 0, and then maybe 1, and then 2 somewhere there, and then this side negative 1, negative 2, negative 3, negative 4, and then let's say negative 5 is right there. Okay, so that would imply the vertical asymptote are going to be these two lines at negative 5 and also at 2. And then don't forget the fact that the horizontal asymptote is y is equal to 0. That implies the x-axis itself is the vertical asymptote. Now you should be able to predict how the graph is likely to come out by just looking at those two simple facts, in that we have the graph, right? So let's try to see now. So I can do a little bit of some testing to just help us. So think of the values that we have. So we're trying to deal with values between -5 and 2 and outside these. So let's start by trying a value between -5 and 2. Let's say 0. If we plug in a 0 into that function, this part is going to be eliminated, and then remain with 20 over 10, which is going to give us a 2. So 0, 2, so somewhere, let's say there. Okay. And then if you try any value of your choice, let's say we try to the right, which is a 1, somewhere here. Plug in a 1 into the function. That's going to be 10 minus 3 minus 1, which is going to be 10 minus 4, which is going to be a 6. Now 20 divided by 6, that is going to be slightly bigger than, because 6 into 20, that's going to be 3 times, giving us 18 with a remainder 2. So it's slightly higher than this point, so it's going to be somewhere there. And then to the left as well, if you try a -1, trying a -1, it's going to be 10 plus 3, that will still be a -1, so that will be 13 minus 1, and then that would be 12. So slightly lower than this point, but again eventually it is going to end up going up again because of these asymptotes. So there's no literal need to overdo it, so you can just approximate. So it's going to be like this, because it can't cut the asymptotes. Okay, so if you draw it more curved, it's going to be something like that. It can't cut the asymptotes. Okay, and then the other sides now, we want to know whether the graph is going to be on top or it's going to be down like this. So just get any simple point. Try a 3. If you plug in a 3, you're going to have 10 minus 9, then minus 9. So probably that's a negative, right? 10 minus 18 is a -8. So we're going to get a negative value if you divide into 20. So that tells us the graph is going to be below the x-axis on the right hand side. Like that. And then the other side, again, try -6. 10 minus 3 minus 6, and then minus 6, that's going to be 36. So 10 plus 18 minus 36, 10 plus 18 is 28 minus 36, that's still a negative, so as well it's going to be down. So something like this. It shouldn't cut the x-axis, it shouldn't cut the vertical asymptote. So that's how this graph comes out on a sketch. So now if you're that person who wants to have more understanding on how you can sketch rational functions, because you've got different types, there may be a case where the highest degrees like that can be the same. Of course, in such a case you'd understand that the horizontal asymptote is x is equal to 0 and whatnot. So you have to now, I don't want to say that, but actually vertical asymptote is x equal to 0. So watch that video so that you understand all the three possible cases, okay, where it's an improper fraction. How do you graph the rational function? So the link is added to the description of this video for those more practice questions that you need.